Okay guys, this time I'm gonna go over 2019 multiple choice calculator session. I thought I made a video about this a long time ago, but looks like I haven't, so here we go. Now this graph represents first derivative, and function f is continuous and close interval 0 to 5. And which of the following interval f is increasing? So you're looking for where original function is increasing, right? In order to increase, basically you're looking for like positive section of the first derivative function. So do you see here to here is positive and here to here is positive? So it's gonna be 0 to 2 and 4 to 5. Okay, so answer is gonna be D. I mean, it's not that bad, right? Now question number 77. The height of the object, this one is this one. Question is what is the velocity of the object? So basically you're looking for the first derivative. So let's do this. First, I don't even have to do it by hand. This one is just calculator. So you just do menu for 1 and you plug in 3. That's all you need to do. So you're going to get 70/9. That's going to be, if you click control enter, you're going to get approximately 7.778. So it's going to be B. All right. Now question number 78. Function is the differentiable and satisfied when x is equal to -1, y is equal to 4. And this one is the slope, right? And what's the approximate of -1.2 using the line tangent? So whenever you see word line tangent, you're gonna use either y equals mx plus b or slope intercept form. So whichever you want. Or like y minus y1 equals slope x minus x1, whichever you want. You're gonna get the same answer. So let me use this one because that's traditional. So y minus y1 is equal to 4 and slope was 2, x minus -1, so it's gonna become plus 1. So you're gonna get y minus 4 equals 2x plus 2. If you do plus 4 both sides, you're gonna get y equals 2x plus 6, right? But question is asking, you're gonna approximate the -1.2 using the line tangent. So instead of x, I will only put -1.2. That's all you need to do. So 2 times -1.2 is -2.4 plus 6. And -2.4 plus 6 is 3.6. So answer is A. Like, it's pretty easy. So question number 79. Tara's heart rate during a workout is modeled by function h of t measured by per minute blah blah blah. Which of the following expression gives a Tara's average heart? Do you say average heart? So that's the average rate of change. So 1 over b minus a and b. That's what you're doing, h of t, right? So this is going to be 1 over 60 minus 30. 30, 60, and h of t. That's what you need to find. So 60 minus 30 is a 30, so answer is going to be this. If you cannot find it, this one can also be some kind of number, like not h, like x of 60 minus x of 30 over 30. This can also be the answer, but I don't see that one here, so who cares? Let's do question number 80. We have a function, so that's the first derivative already. Is equal to this one, where x is greater than 0. And according to the question, g of 2 is equal to -7. So you want to find g of 5. Well, do you see this one is the first derivative already? So if you want to find g of 2, you have to anti-derive it. So, but do you see x is going to be 2 to 5? So let's set it up. This is a typical question that you will always get. 2 to 5, g inverse of x dx, right? That's gonna give you g of x from what? 5 to 2. So which is 5 to 2, right? So let's do this. Now first, this portion, you're gonna use calculator. So on the menu for 2, you are going to put this one in, x to the third power plus x dx. That is equal to g of 5 minus g of 2. Because when you actually do it, you're going to get this one, right? So remember this portion. You're going to have at least 3 questions that looks like this on your test. Now, when you put this one to the calculator, you're going to get 20.899 equals, we don't know what g of 5 because that's what we're trying to find. So I'm going to put g of 5 minus, we already know what g of 2 is, which is negative 7. So it's going to be negative 7. It's given to us. So negative times negative is a positive. So if you want to solve for g of 5, it's a 20.899 equals g of 5 plus 7. I just rewrote it. So I'm going to do minus 7 both sides. You're going to get g of 5 is equal to about like 13.899. This. So keep that in mind. When you do this one, antiderivative of first derivative will become g of x. And now you got to plug in 5 to 2. So this is this one, as you know. But usually and still, since we don't know what g of 5 is, but we know what this is, I just plug this one in as a 7. This one I just used the calculator to get this one. And then I solve for g of 5. Like, this is how you do it. And this one is pretty easy, okay? Now let's do 81. It's simple as well. If f is a function that has a removable discontinuity, so removable discontinuity is this one. Which means as long as I connect this one, that's going to be continuous, okay? At x equals 3, which of the following could be the graph? So let's look at this. Do you see this one's disconnected? So that cannot be the answer. This is also disconnected. This is also disconnected by the asymptote. So this is the answer. Because as long as I fill this one in, that's going to be continuous. That easy. 82. This question, again, I told you you're going to have 3 questions like this, right? You're going to see this type of question in the multiple choice non-calculus session as well. This one is very similar to this one as well. Not quite similar, but pretty much same concept, okay? So watch this. Actually, it's not even same. Never mind. It's not same thing. Now you have this one. And you want to find 0 to 13. So let's see if we can make 0 to 13. How can we do this? 13 to 20 is 7. How can we set this one up? Maybe I will put 0 to 17 f of x plus 17 to 20 f of x is equal to same thing as a 0 to 20 f of x, right? Which will become 8 plus negative 3 is equal to, we don't know what that is, but 8 minus 3 is going to become 5. So now we know, because 0 to 20 is equal to 5. And in order to get 0 to 13, this minus this will give you this, right? Or I can just write 0 to 13 f of x plus, now I'm going to use this one, 13 to 20 of f of x is equal to, still now it's going to 0 to 20, right? So we know we don't know what this is, so I will just write down here. Plus, now we know what this is. That's going to be what? 7 plus 7 is equal to, this one we just got it here, which is 5. So minus 7 both sides, we get 0 to 13 f of x is equal to negative 2. So you can just do it like that. It's pretty simple, okay? Right now I used a lot of space here, but when you feel used to it, I swear you're going to do it faster and easier, okay? Let me flex here. Do you see? All right, so question number 13. I believe this is the last question that I will go over in this video, and I'm going to make the second video. Now let f be a function defined above here, and k is a positive constant. So most likely we're going to solve for k. what value of k, if any, f is going to be continuous. Now, in order to be continuous, this should be equal to this, okay? So, k to the third power plus x should be equal to 16 over k squared minus x when x is equal to 3, okay? So first, let me plug in 3. K to the third power plus 3 is equal to 16 over k squared minus 3. Now we gotta find this one. First, I'm gonna move this one to this side. So what I'm gonna do is multiply by k squared minus 3 here, here. So these two disappear. I have k squared minus 3, k to the third power plus 3 equals 16. Like that easy. And if I wanna solve for k, I'm gonna move 16 to the other side. So I'm gonna make it as k squared minus 3, k to the third power plus 3 minus 16 is equal to 0. Yep, so only thing that I have to do is I'm gonna use this one, I'm gonna put this one into the graph and find x-intercept. I think it's the menu, analyze graph, and then x-intercept is like 0. Find something is a 0. I think menu 6, 1, something like that, okay? Then you will find x equals 2.08, right? That's what it is. So remember, you're gonna have a 2x intercept or more, but you're looking for positive constant. So you have to find positive number, all right? So that's about it for this video. I will go over more questions for next ones, okay? That's about it. See you guys. I love you. As always, bye.